In this short talk, we'll deal with bar charts and histograms and contrast the two of them and show what's meant by each. Excuse me. So, bar charts and histograms are used to compare the size of different groups. So, to that end, we use them interchangeably. We can look at the size of different groups by looking at bar charts and histograms. Let's start by looking at bar charts. Well, a bar chart is made up of a column or of a set of columns plotted on a graph. So it's a column on a graph. And the column represents some variable. We call it a categorical variable because it denotes some group or some issue that we're identifying. It's not necessarily measurable. It's identifiable. We'll explain what I mean by that in the coming slides. The columns are positioned over a label that represents this categorical variable. So we could say the column represents people who live in London. That could be our categorical variable. Our categorical variable could be people who play football. That's our categorical variable, as opposed to people who play snooker or play rugby football. So we have different categorical variables. In other words, the categorical variable tells us what the column represents. The height of the column indicates the size of the group defined by the column. So the taller the column, the more that's in there. Let's take a bar chart that shows the number of car sales in different centres of the UK in May 2016. Not real data, I just amended this data to illustrate what we're doing here. So let's take our fictitious data. We have car sales in different regions: London, Birmingham, Leeds, Manchester and Bath. And if we represent this in a bar chart, we can see London has more sales than Birmingham, which is more sales than Leeds, and so on. And the categorical variables here are where the sales took place. London is a categorical variable. It tells us where the sales were. And we can just look at London in this case and say, well, more was sold in London than, say, in Birmingham. Birmingham is a categorical variable, as is Leeds and Manchester and Bath. So, of course, we can criticize what we got there as being very simplistic. London is much bigger than Birmingham, so we would expect more cars to be sold in London. So we should have refined the data to make it more precise and it gives us more information. We should say perhaps the car sales in London per 1,000 of the population. Well, that would be a more accurate figure. But we didn't. We're just illustrating bar charts here, so that's what a bar chart would look like. Now, histograms. Well, like bar charts, a histogram is made up of columns plotted on a graph. We just saw columns on the previous graph. Well, here histograms are columns on a graph as well. However, there's usually no space between the columns. Usually the columns are contiguous. They touch each other. So they're almost joined up. The columns are fit closely together. The columns represent quantitative data, quantitative variables, I should say. So they're measurable in that sense. The heights of the columns represent the size of the group defined in the column. So we can look at what we mean here. Let's take a very simple example. Let's say we take a histogram that shows the amount that we spend on holidays for different groups, different age groups. And we say, let's say this applies to 2015. So let's say we've got data for 2015 of people who go on holidays and we were able to categorize them according to age. So now we have teens, then we have people from 20 to 29, people from 30 to 39, then from 40 to 49, and so on. And on the vertical axis, it's the average amount that they spend when they go on holiday. We can see immediately from the histogram that people aged 40 to 49 spend more. People over 70 tend to spend less, but so also do teenagers spend less. Perhaps they are saving for some particular function or some particular product. They want to buy a car, they want to buy a house, or people over 70 don't want to spend a lot of money on a lot of arduous traveling, or so it depends. But it's essentially what the chart is telling us is who spends most money on holidays. And here we've got the amount to spend on the vertical axis on average, and on the horizontal axis the age group associated with that expenditure. Now the difference between bar charts and histograms, well, bar charts, each column represents a group defined by a categorical variable. And remember, I said categorical variables were just ways of naming the group. So the number of cars sold in Birmingham, the number of cars sold in Manchester, the number of cars sold in London. So the categorical variable was cars sold in London, and that would define that column. That's the categorical variable. With histograms, each column represents a group defined by quantitative variable. So there are groups defined by quantitative variables in the histogram. Now histograms, of course, may be skewed. We don't have to have symmetric histograms. We might find when we plot the histogram that the median, the mode, the average, they're falling in different places. They don't have to all fall in the same place. If it's symmetric, all of them will coincide. But if it's not symmetric, they will fall in different parts of the distribution. And we may find that histograms are skewed. In fact, it's quite common. Charts use categorical variables, and these cannot be analyzed quantitatively. We can't, if we go back to our example with car sales again, we can't take London and Birmingham and take the average. There is no such thing as an average. We can't add London and Birmingham together and divide by 2. It doesn't mean anything. So we can't analyze categorical variables quantitatively. We can just look at the pictures and try to work out what's happening from the size of the columns and the positioning of the columns perhaps, and so on. But we can't analyze it quantitatively. So we can't use the concept of skewness in the context of charts. If we remember the chart I had earlier, London was on the left and was the tallest, so it would look like it was skewed. But it doesn't make any sense. I could have positioned London on the far right. I could have positioned London anywhere in that chart. So we can't have concepts like skewness in the case of categorical variables. So now we should know the difference between bar charts and histograms. Histograms are amenable to quantitative analysis, whereas bar charts use categorical variables. They are simply pictures representing areas or representing particular products or whatever it is they're representing, and showing perhaps the number sold of that product, and that can be positioned beside a different product and the number sold of the different product. But no analysis can be done. We can't compare them statistically because they are different products. But with histograms, we can do more analysis with histograms. And that's all we're going to deal with here. So let's leave the topic of bar charts and histograms and say thank you for watching.